Hello students. Hello everyone. I am Nazma. I have 7 years experience of teaching in various institutes. Today my goal is that the subject which is very complex, to make it very simple and deliver to it by solving the problems. And today we'll deal completely about the physics. So we'll see the physics syllabus and how important this physics syllabus in our exam. So now in the NEET exam, we have physics, biology, chemistry. So we get here 90 questions from the biology and 45 here, and from the physics 45 questions. And we people are very scared about the physics. But one reality is that physics will deal everything with the real life. In the daily life, whatever we do, that deals with the subject that is physics. So scoring the marks in physics is very easy. The way of studying the physics is that we study with the real life examples and implement here. If you see the syllabus of the physics, we have many topics like units and measurements, laws of motion, kinematics, thermodynamics, work, power, and energy, and oscillations and waves, and we have current, electricity, electrostatics, and like this we have 20 topics in the physics syllabus. So in short, we define into 3 ways, that is modern physics and electricity and the remaining topics. So scoring the marks in the physics is very easy. Just you have to follow the few steps, that understand the concept very well and familiarize the formulas, and ratta to nahi marna, just you have to know the formula. If you know the concept, you can go over the formulas, because in the physics we guess most of the 20 to 25 questions around will get based on the formulas. So which means we should give importance to the formulas, at this remaining questions will be based on the concept, that are numerical problems. And these numerical problems also will deal completely with the formulas. Where the application of formula has to be done, that has to be known to us while we are preparing for the physics exam. So most will be based on the formulas. Clear? So before that, we'll see some of the real life examples in this. If we take the real life examples, it will be very easier for us, and you will say that physics is one of the easiest subjects that I can score the marks. So before going for a real life example, let us know some of the words definition, that is electron, we'll know some of the definitions. Electron, next what is the charge, everything. Electron, I'll say some of the key points about this. Electron is a negative charge. And electrons moves very faster around the nucleus. around the nucleus. And this electron is a tiny particle which we cannot observe by our eye. It's a tiny particle, cannot observe by our eye. So we'll see what is the major role of electron in complete electricity, complete electric current, magnetic effect, electric effect, electrostatics, in everything. We'll see what is the importance of electron. Next, we'll see what is a charge. Charge is also a tiny particle, charge. Charge. Charge is also a tiny particle. See, this charge is divided into two types. One is the positive charge. One is the positive charge. The other is the negative charge. So, positive charge and negative charge. If we observe the scenario between the positive and negative charge, the both positive and the positive, negative and the negative, they will repel each other. They will repel each other. If there exists a positive and a negative, this attracts each other. Attracts each other. If two positive or two negative charges have been taken, then they repel each other. For example, if I take two fields like North Pole and the North Pole, South Pole and the South Pole, these are the two magnets. If you observe, two magnets or two fields or two poles, then there will be repulsion occurs, repulse. If you take one North Pole and the South Pole, then the magnets will attract each other. Yes, clear? So, one positive and negative attracts each other. These are the charge. And charge is a very tiny particle. Clear? Now, as we know what is the electron, what is the charge, we will know what are the quantities. Scalar quantity, we have two quantities. One is the scalar quantity, the other is the vector quantity. Coming to the scalar quantity, scalar quantity will have only the magnitude, no direction. Scalar will have only magnitude. No direction. No direction, which means same in all directions. So it consists only the magnitude. Same in all directions. For example, if you take the scalar quantities examples like 70 kgs, 5 meters, 30 degrees. If you observe the example 70 kg, I am mentioning only the magnitude, not the direction. 5 meters, and specifying the distance. The distance is magnitude. 30 degrees Celsius, which I am mentioning only the magnitude, not the direction. So that is the scalar. Next, we will see what is the vector quantity. Coming to the vector quantity, it will have both the direction and the magnitude. Both the magnitude and direction. So vector, both magnitude and direction. If you observe the example, so I want the magnitude and the direction. So can I take 70 km/h? Yes. And specifying the magnitude, 70 kilometers is the quantity, magnitude per hour, that is the direction. And one more thing, 50 meter east. 50 meter east. 50 meters is the magnitude and east is specifying the direction. So this is also a vector quantity. Clear? So scalar and vector. So while preparing you feel some confusion. What is the scalar and the vector? I'll say simple trick and the tip. You just follow that. Scalar. How to remember the scalar? Scalar, just remember how much. How much. Vector, you remember how much plus direction. how much plus where or why. If you remember these two terms, how much plus where, you can easily write any problem if related to scalar and the vector comes in the examination. Clear? So now we'll see about the electric current. Madam, why after scalar and the vector the electric current comes? We'll see that. Electric current. Electric current. So we'll see. I have taken a conductor. Taken a conductor. And that conductor is a metal conductor. First step is I have taken a conductor and that conductor is a metal. We know that in the metal we will have the free electrons. In metal we have the free electrons. As I have said before that electrons are negatively charged. Clear? So in a conductor we have a free electrons. Now if we observe this, in the conductor whatever the electrons, free electrons present, are they moving or in the rest position? As they are in rest position. Nothing but a static position has been in the conductor. Now what I have to do is I have to move the electrons. I have to make some motion to the electrons. What I have to do? Simple. I'll connect a battery to this. I'll connect a battery to this conductor and I'll create a motion for the free electrons. So this for a battery, this is a positive charge, this is a negative charge. This is a positive charge and this is a negative charge. Now electrons will always attract the positive charge because electrons are negative charge. As before I have said, the positive and the negative, they will attract each other. Negative and the negative will repel each other. The same scenario will be applicable here. This is positive charge. For a battery, this is positive charge. Definitely for this conductor, this terminal will be positive. So the electrons will attract in this way with respect to the positive. Now if you observe, the negative charge is connected, the negative charge of the battery is also connected to the negative terminal of end of this conductor. Electrons will have the negative charge and these two will repel each other. And if you observe this both conditions, the net force will be in this direction. This is the net force. So the motion of the electrons will be in this direction. So the motion of the electrons will be in this direction. But I want the direction of the current. See, in general, electric motion or electron motion, the currents will always flow opposite in direction. The current always flows in opposite direction. This is very important. Current flows always to the opposite direction to the electron's motion. Now, the electron's motion is entering into the positive charge, but the current has to flow in the opposite direction. Now, the current direction is this. Clear? So, in this way, the current will be generated and the electric current will be produced. And if you observe this positive charge, I say this is as a high potential, and this is a low potential. So always the current flows from high potential to the low potential. For example, in the real time example, I'll say, in general we have the water tanks on the roof of our house, top of our house, the water tank. So the water tank. So water tank is electric current, and the pipe we use there from top to bottom, it has to come. If you observe this diagram, this is the tank of our home, and from this the water comes to our home, our house. Yes or no? This is the bottom. I say this tank has a electric current and this pipe has a wire. And whatever the water that flows in this pipe, whatever the water that flows, I say that as electrons. And this is the final. In this, whatever we are utilizing, that will be electric field. Yes or no? If you observe, so everything we know how the current has been produced from this diagram. But what you have to observe is that the tank is placed in the high potential, very high height, more height, and the whatever the water we are utilizing at the low height, bottom, in the bottom way. So the current is flowing from high potential to the low potential. This is very important. High potential to the low potential. So this is the one of the point you have to remember, high potential to the low potential. And one more thing, just take a balloon, rub on your hair, and if you rub continuously, whatever the balloon, that will be a negatively charged, and whatever the hair on the which you have rubbed, that will be a positive charge. If you rub there, the balloon will stick to your hair. The balloon will just stick. Nothing but here the positive and the negative are being attracted each other. There also we are getting some electric current, electric potential we are getting. Yes or not? In the real time. So all this happens in the real time, but what we do is, according to the subject, the terminology varies. That's all. In every and each subject, the concepts are very similar, but the terminology we are using, that is different. Clear? Now, one more example, let me give you. If you see the natural lightning, during the rainy season, the lightning occurs. How the lightning occurs? Due to the clouds will have the high volt, millions of volts. Due to that, the high potential created over there in the clouds, that will be dropped to the ground, because the ground will have the 0 volt potential. 0 volts potential. That's why it will drop to the earth. So natural lightning also will have the high potential to low potential. So, and if you observe this example again, this water tank, we can conclude by one point, that is that more height, more potential. If there is more potential, more work can be done. Yes or not? In the same way, we the human beings, if we have the more energy, definitely have the more potential to do the work. More work. And so more height, that is, which is nothing but the more potential, that is more work. And one more, let me give one more, an idea that, see, in a conductor, the electrons flows. You know, you have said the direction also, how the electrons flows, how the electric current has been generated. So is this electrons move faster from one end to other end? Is this electrons move faster from one end to other end? No, it will not move in the faster way, because number of electrons are present. Not only a 10, 20, 30, 40, a millions of electrons has been generated. Number of free electrons has been done. And the passage from one end to other end of the electrons, and there will be some collisions over there. And that collision's time is known as relaxation time. That collision time is known as relaxation time. Yes. So this is the complete scenario about the electric current. Now we have discussed what is the electric current. Now at last we'll make a statement that whether electric current is a scalar quantity or a vector quantity. So scalar means which have the magnitude, but vector which has magnitude and the direction. We will check over that. Electric current. The most confusion question is that electric current is a scalar or a vector. scalar or vector? Most probably we say that electric current is a vector quantity, but no, electric current is not a vector quantity, because actually in our mind, the student mind, what says is that, see, electric current will have the magnitude and also it has a direction, because current has some direction. So we can say that it is a vector quantity, but no, electric current is a scalar quantity because it has a magnitude, the current has a magnitude, but the direction is already fixed by the conventional directions. In this electricity, we do everything by the conventional directions. It will be fixed by the conventional direction. So that's why electric current is a scalar quantity, not a vector quantity. For example, if a wire carries a 2 amperes current, and another wire carries 3 amperes current in a junction. What is the total current? We'll say simply as 5 amperes. No, we are not doing any vector sum addition over here. We are not doing any vector sum addition, and we need not follow any vector rules also over here. Clear? So I'll say some of the scalar quantities, example, which are very important. Scalar quantities. The first is electric current. Resistance. Third is capacitance, inductance. So these are some of the scalar quantities. Coming to the vector quantities, magnetic field is a vector quantity because it should have some direction, because whether the flux is passing from the north pole to south pole or south to north, definitely a direction should be included in the magnetic field. Otherwise, the Faraday's law, the Fleming's right hand rule, the Fleming's left hand rule, everything will not work over here. The second is electric field. For the electric field, the passage of flux lines also we have to know if it is a vector quantity only. So these are some of the vector quantity examples. Clear? So finally we can say a statement that electric current is a scalar quantity, not a vector quantity. Already we have taken an example and I have said the water tank. Because the water tank, here a potential difference occurs and the current flows from high potential to low potential. High potential to low potential. Definitely there exists a potential difference. Clear? So, a simple example. So, there exists a potential difference. So, we'll have a simple example of that. And coming to the potential, electric potential, the definition for the electric potential will be the potential difference, the creation of potential difference, in simple, the creation of potential difference between two bodies or any objects or etc. So this is the electric potential. Clear? Thank you. Thank you everyone.